Good day to you all. My name is Devinder Basuta and I am the Photonics Business Development Manager for Europe for Glenair. This presentation is covering Glenair's ruggedized optoelectronic and photonic solutions for high-speed optical communications. Glenair has been an industry leader since 1956. We're privately owned and we have approximately 2 million square feet of factory space worldwide. Our core products are connectors, accessories, wire protection, cable assemblies, and of course optoelectronics and photonics products. And the primary markets we address are all requiring harsh environment solutions, so defense, aerospace, oil and gas, mass transit, and space. The company has a major focus on new product introductions, and we operate a very service-centric business model. Glenair also is compliant with AS 9100 Revision D and ISO 9000 quality standards. In terms of our global presence, Glenair is headquartered in California, in Glendale, Los Angeles, with further facilities in Anaheim, in Southern California, and in Chicago, in Illinois, on the East Coast. Regarding Europe, we have three main operational facilities. The first is in Mansfield, in England. The second is in Bologna, in Italy. And the third, which is focused entirely on space harnessing, is in Salem in southern Germany. And then in addition to this, we have an operation in South Korea, in Seoul. So our core photonic product line includes PCB fiber-optic transceivers, PCB mount fiber-optic transceivers, and these transceivers cover a range of applications from low speed, from 50 megabit per second up to 10 gigabits per second per optical fiber data rate. They're available in a range of different wavelengths, from first window 850 nanometers to second window 1310 nanometers to third window 1550 nanometers, and in addition on the coarse WDM grid as well. These parts are available both in multi-mode and single-mode fiber applications and are optimized for both video and data signal formats. So for video it could be HD SDI or 3G SDI. Data it could be fiber channel, Ethernet, ARINC 818, and any related balanced digital signal protocols. The three pictures you see here show here on the left our two-channel fiber optic transceiver. These could be a transmitter and a receiver, or both channels could be the same, a TX and a TX, or an RX and an RX. In the center here we have a single fiber, a single port bidirectional transceiver. This uses two different wavelengths to send signals in full duplex over the same fiber. And here on the right is a 4-port version of a transceiver. So again, this could be 4 transmitters or 4 receivers, or a TX, RX, TX, RX configuration. Our core product range also includes PCB mount parallel fiber optic transceivers, and this shows you the form factor of our main product. The different configurations available for this are an 8 fiber configuration comprising 4 transmit and 4 receive channels, or a 12 fiber configuration where each of the 12 fibers could be transmitters or receivers. In the case of the 12 channel, then you'd need a 12 channel transmitter at one end of your link and a 12 channel receiver at the other end of your link. This photograph here on the right shows the module mounted on an evaluation board which Glenair can supply to our customers for simple and easy evaluation in the lab. So with this configuration we can offer up to 14 gigabits per second per optical fiber, This product runs at 850 nanometers wavelength over multi-mode fiber. And then from a functionality point of view, this part is equivalent to the commercial QSFP Plus or commercial CXP protocol standards. Under development for PCB mount optical transceivers are quad optical transceivers using 8 fibers of 4 by 10 gigabits per second, 4 by 25 gigabits per second, and 4 by 56 gigabit per second as a longer term development. As I said, this is under development, and these are low profile compared to the previous transceiver that you saw. So the height and the footprint of these parts is much less. Also, these will be available in 2 different variants. Here you see the permanently pigtailed variants, and here you can see a variant which is connectorized, which takes an empty ferrule based parallel optical ribbon fiber connector to connect to it. So these are the 8 fiber versions, and then we have 12 fiber versions as well, 12 times 10 gigabits per second and 12 by 25 gigabits per second. This exciting new range of products will be introduced over the coming year. Here at Glenair, we've also been working on optical components for laser communication terminals, for free space optical links for satellite to satellite and satellite to ground station applications. These products are targeted at the low Earth orbit constellations that are being designed and launched by various satellite operators across the world. For these applications, we're offering ruggedized optical transceivers, and this is a photograph here of our dense WDM optical transceiver, which is available on the 100 gigahertz ITU C-band optical grid. This is used in partnership with our fiber-optic amplifiers. These amplifiers can boost the signal coming from the transceiver up to levels of around 5 watts in the optical fiber. And then on the end of these very high power jumper flying leads, we've developed very high power handling fiber optic connectors to be able to connect and disconnect the very high power interconnections that are generated when using fiber optic amplifiers of this level of wattage. Now, our transceivers, as I said, are typically targeted for ruggedized applications, and this list here shows you the typical environmental qualifications that we carry out on our parts. So accelerated aging at 85 degrees C for 2000 hours, temperature cycling of 1000 cycles from -55 to +125 C, vibration at 45 and 54 G RMS, 2 hours per axis, shock 650 G, 0.9 millisecond pulse duration for 10 shocks per axis, humidity as per mil standard 883, and also radiation exposure testing as well, both for gamma and neutron, proton and heavy ions. Radiation testing is ongoing. We have an ongoing program for increased testing regime for new products as they become released to market. I must say that these tests that are outlined here are conducted whilst the transceivers are operating, and during this testing they show no degradation in signal or deterioration of the bit error rate. Now, moving on, our core photonics product line also includes connectorized fiber optic transceivers, and these connectorized transceivers use optical contacts, as you see in the picture here on the left, that are active size 8 optoelectronic contacts. These contacts can be either a laser or a photodiode receiver, and they are designed to work from DC up to around 5 gigabits per second at a wavelength of 850 nanometers, supporting multi-mode fiber applications. Once again, these contacts are optimized for various video and data applications. So we do support HD SDI, 3G SDI, fiber channel, Ethernet, ARINC 818, and other balanced signal digital protocols below 5 gigabits per second data rate. And in these pictures here, you can see these contacts implemented in different connector types of interfaces. So this is a regular circular D38999 type of connector. This is an ARINC type of backplane connector. This is a new product we've developed, which is a D-sub type blind mate connector. This is available for 1, 2, and 4 channel wide and configurations. And this is another circular connector configuration. And of course, the world is not entirely optical, and we can combine these optoelectronic contacts with electrical pins as well. And here's an example of some parts that we've recently made for specific applications. So here you can see 2 optoelectronic contacts, 2 very high speed of our LO Cheeto contacts. These are rated for 10 gigabit per second data rates, along with some smaller signal pins. And so on. Well, we can make very custom solutions depending on the customer's requirements for signal, power, and optical connections. So we use the components that I've described in previous slides also to make plug-and-play electrical to optical media converters. And plug-and-play essentially means that you connect power, you connect your optical signal, you connect your electrical signal, and instantaneously you've converted your equipment to run from copper onto optical fiber transmission lines. And pictured here are a number of photographs of different mechanical profiles, different connector interfaces for different applications where we've designed these media converters. So typically these media converters are available from data rates up to around 5 gigabits per second, again optimized for video and data signal formats. We can also make signal aggregators by which we can aggregate multiple copper signals onto 1 or 2 optical fibers. And this is very useful when you need to try to reduce the weight of copper conductors in, for example, avionic applications or in UAV applications, or for that matter, when you're putting signals through a fiber optic rotary joint, for example. In terms of wavelengths, these are available right across the board in all the common communication wavelengths, both for multi-mode and single-mode fiber. And as you can see in these pictures, they are available in multiple different connector interfaces for connecting the cables and the jumpers. So most of you will know Glenair as a connector company, and we are indeed an expert in both electrical and fiber optic connection systems. I just wanted to highlight one particular development that we are offering for avionic and space applications, and that's our new Series 79 MT fiber optic connector. This connector is available for a single MT ferrule, dual MT ferrule, and quad MT ferrule configurations. So if you imagine each single MT ferrule can hold up to 24 optical fibers, potentially a 4 MT ferrule connector like this can connect or disconnect up to 96 optical fibers in one go. So these connectors offer a very small form factor, high density, mil-aero qualified solution for connecting and disconnecting multiple fibers at a time. And these are finding use for parallel optics applications in optical backplanes, in missile systems, head-up displays, in fact anywhere where you need to manage a very large number of optical fibers. So putting all of the above building blocks into a single picture, what's our value proposition? Well, we offer the fiber optic transceivers, the actives. We offer the backplane connectors in terms of the very high density fiber optic ribbon fiber connectors. We offer breakout cables, jumper cables in a variety of different optical fiber connector formats. We are now also offering what we call fiber flex, and these are, imagine flexible optical fiber circuits sandwiched within polymer layers, which can be custom built to provide the connectivity required from within the board, from board to board, and from board to backplane. And putting all of these building blocks together in a system like this offers a very powerful optical interconnect solution. And on that slide, I'd like to thank you for your attention. I'm based in the UK. Here are my contact details, and I very much look forward to hearing from you in response to anything that may be of interest for you here.